Chemical engineering is concerned with the design, construction, and operation of machines and plants that perform chemical reactions. These activities produce waste. This leads us to ask, what happens to the waste that results from these processes? This podcast aims to answer that very question. This is Franz Camaro, a chemical engineering student from Xavier University Ateneo, and I will be your host for today. This is the Pollution Control Podcast. Due to popular demand, we have yet another episode about pollution control. Today, we are going to talk about the proposed air pollution control for the same plant designed by our previous researchers. Welcome to this episode entitled Air Solution for Air Pollution. There are multiple sources of air pollution. These include industries, fossil fuels, agro-waste, and vehicular emissions. Upgrading industrial processes, energy efficiency, and fuel conversion are significant aspects to reducing pollutants which create industrial air pollution. We have with us our guest speakers to discuss the Air Pollution Control Initiative and their proposed plan. Reintroducing our researchers, we have Frances Nona Atasan, Vanessa Balaba, and Ivander Bumanglag. Hi guys, and welcome back to the show.
Hi Franz!
Thank you for having us again.
Yes, thank you so much.
So, just a quick recap. There are 10 equipment used in the project, right?
Yes. We have the dryer, air heater, blower, screw feeder, furnace, fluidized bed reactor, cyclones, condenser, centrifuge, and the nanofiltration setup.
Which of these equipment discharge gas?
The only equipment that produces harmful gases is the fluidized bed reactor. It discharges flue gas and pyrogas. Pyrogas is gas produced from the pyrolysis process.
How much of these gases are produced per day?
Based on our calculations, the flue gas produces about 2,328.22 kilograms per day, and the pyrogas produced is about 2,043 kilograms per day. The pollutants in the pyrogas are carbon dioxide and methane.
So, what system has the team decided on managing these contaminants?
We have decided to incorporate a wet scrubber. So, a scrubber system in general is used in the removal of harmful and hazardous particulates from industrial gas streams before they are released into the environment. There are actually two different types of commonly designed scrubbers, which are wet and dry. So, dry scrubbing is done by using solids or slurries to bind the contaminants, while wet scrubbing uses water to wash out the contaminants. A wet scrubber is incorporated because it is commonly used by most industries.
For the sake of our listeners, how does a wet scrubber work?
So in a wet scrubber, a fan is used to forcefully guide the polluted gas stream through the inlet side of the scrubber through pipes and ductwork. The contaminated gas will be in contact with the water, which is most often sprayed from a nozzle. As the gas meets with water, the particles will stick together and form larger droplets. The vessel will be equipped with mist eliminators, which will then serve as a filter. The droplets will be collected in the filter and will eventually fall to the bottom of the stock where they can be collected for removal.
Scrubbing is actually called an absorption phase. In this phase, the gas components have turned to liquid. Chemicals or microorganisms can also be added to the scrubbing liquid to neutralize the gases that are dissolved in the liquid.
Wet scrubbers are unique because they can handle gaseous and particulate contaminants in one technology. So these are extremely safe and can be designed to handle high temperatures, high humidity, corrosive chemicals, and liquids.
What were the considerations you assessed when deciding on the design of the wet scrubber?
The first characteristic we thought of was the orientation of the scrubber because a wet scrubber can either be vertical or horizontal. We decided on the wet scrubber being vertical since it is typically recommended if the rate liquid accumulation is small. We assumed a small liquid accumulation because the discharge flow rates of the gases are not that problematically high. Vertical scrubbers also have higher removal efficiency than the horizontal ones.
Scrubber should also be equipped with a system fan, a cycle pump, instrumentation and controls, mist eliminators as mentioned earlier, and exhaust stack. It should also be corrosion resistant. The operating process conditions were also assessed such as flow rate, temperature, concentration, removal efficiency, and the chemical compositions removed.
To add on, the mist eliminators must be lightweight and durable, should not interact with the chemicals, and the material must have a path for the liquid to flow, as well as to allow contact between the liquid and the gas. Because if liquid cannot flow, there will be a high pressure drop, which will impact the performance and efficiency of the equipment.
Really thought this one through, huh? Moving on, what is the mitigation of air pollution control systems in compliance to?
The air pollution control we incorporated is in compliance with Republic Act 8749, which is known as the Philippine Clean Air Act of 1990. This act encourages cooperation and self-regulation among industries through the application of incentives market-based instruments.
I presume the DENR spearheads this mandate, right? So what are the DENR's main initiatives on this matter?
The DENR's priority activities are first, monitoring of the compliance of firms or the industries, second, operationalization of airshed governing boards, and third, calibration and maintenance of air quality monitoring stations. Since purged gas contains carbon dioxide and methane, which are harmful air pollutants, air quality monitoring systems are mitigated.
Has the team incorporated an air quality action plan?
Yes, Franz. So, in order to provide a basis for the comprehensive air pollution management and control program of the proposed plan, the Philippine Clean Air Act requires that an integrated air quality improvement framework be developed.
Ah, I see. So what is adopted in this framework?
The Integrated Air Quality Improvement Framework defines goals and supporting management strategies and control measures intended to achieve healthful air in the area. So this includes the emission reduction goals, time periods for achieving the emission reduction goals, the institutional framework to support the implementation of the Integrated Air Quality Improvement Framework, and other supporting elements such as description of economic incentives, collective action, and environmental education and information. In addition, the Philippine Clean Air Act simultaneously requires a national air quality control plan.
Right, because it's intended to spell out specific methods and means to achieve the intent of the Philippine Clean Air Act using the strategy described in the framework. What is further included in the control plan, Nons?
The National Air Quality Control Plan includes enforceable air emission limitations and description of other control measures, schedules and timetables for compliance, a description and designation of airsheds to be utilized as part of the air quality management strategy, a description of program to prevent significant deterioration of air quality, a program to enforce the requirements of the Philippine Clean Air Act, and other measures necessary for the effective control and abatement of air pollution.
Wow, that's a handful.
It truly is, Franz. To add, we must also comply with the national emission standards for source-specific air pollutants and national ambient air quality standards, and secure our permit to operate prior to operation.
Truly, a lot of work and money goes into the control of emissions that might affect the quality of our air. We do all that so that we can continue to enjoy free and fresh air. You can't put a price on that. When we put that into perspective, all that hard work doesn't seem like work at all. Wouldn't you agree? Alright, so that concludes our episode for today. Thank you so much to our guest speakers for gracing us with their valuable time. Van, Nons, Ivan, thank you. And to our audience, Thank you so much for sticking up until the very end. It has been a pleasure. I am Franz Patrick Camaro, and this is Air Solution for Air Pollution. See you next time.